Maurizio Gazzola. I am head of optical architecture in Cisco, and in this session we will go over the routed optical networking, optics, and optical overall strategy. We'll go over optical industry trends, then a little bit on what is router optical networking. Then we'll go over what are the optical innovation that we see in the market. We speak about what is artificial intelligence for optical, and we'll go over the coherent optics latest update. In terms of trends, so what one of the main highlight that I would like to do is the fact that we see a strong movement in the industry, especially about the wavelength generation market. If you can see these those pillars, I would say till 2020, the vast majority of the WDM interface were transponder based. What we see later on, and 2021 was really I would say one of the year where we see the delta, even if that will be consolidated in 2022. We saw that the pluggable interface, so the coherent interface, initially CFP2 DCO, then QSFP-DD, that were placed directly on the router, on the switch, also on the OTN cross-connect port, are driving the majority of the wavelength generation interface. And this trend is more and more accelerating. In 2024, the expectation is that it is more than 65%, so 2/3 of the wavelength that will be sold and deployed in the world will be coming from coherent interface, and then the trend will explode, of course, when more and more with the 400 gigabit will consolidate and will become a mass market, then with 800 gigabit, and later on with the 1.2 terabit and 1.6 terabit wavelength. Transponder will still have I would say, a window of operation, but the market will be dominated by the coherent interface. While for that, because it is the advantage of the coherent interface in terms of cost, in terms of saving of TCO, is, I would say, unmatchable by any transponder. Another trend that we saw in the market is the open networking. So we won't see any more systems that are closed, in the sense that we are speaking about open line system. The WDM must support alien wavelength. So nobody's asking anymore a WDM system that is closed, in the sense that can work only with the transponder of the same band. That is absolutely not requested anymore. On the other side, it is mandatory requested that all the WDM systems are open. The same for coherent interface. There are multiple standards of MSA that are driving interoperability from different vendors of coherent interface. And finally, of course, also the management. There is the trend not to have a single management system closed with the vendor, because the vast majority of the network are multi-vendor, are multi-domain, multi-layer. So the concept of management that can collect all of those aspects is another trend in the industry. Another trend is the capacity. Now, I would say C-band is the classical transmission. L-band is out since a while, but actually nobody are really using a lot of the L-band, beside, of course, some hyperscaler, even if everybody is asking the capability to upgrade to L-band in a no traffic affecting way, in order to be sure that whatever is deployed today will be granted to be future-proof. What will be next? Future will be probably the S-band, in case when the L-band will be fully concrete in the future, a possible expansion will go over S-band that are already studied and the university project running on this. On the other side is another way to increase the capacity is with the more fibers. So there is a trend with not only more fiber in the same cable, but is a trend to apply what was done for the submarine with the multi-core fiber, so a fiber that inside the same medium. Before there was one core. Here there are studies to have multiple core. Here an example of 4-core fiber, so you can multiply by 4 the capacity. Another interesting is the hollow core fiber that is came up very in hype when Luminicity, that was a company that was producing this kind of fiber, was acquired by Microsoft, and everybody asked why. The fact that with the hollow core fiber you can dramatically increase the speed, because the speed of the light in the vacuum, the hollow core doesn't have a core with glass, but has a core with vacuum. It's completely empty. The light is entrapped inside, and you have with this data you can a 50% improvement in latency, because the speed of the light in the vacuum is 50% more than the speed of the light in the glass. Where there are those fiber at the moment, I would say we would expect 1 or 2 years before to have mass production, but it is something that we expect to absolutely come into the market. Another aspect is everybody, are under pressure with the cost of the network. We are not speaking about capex. If you see the vast majority of the network operator are focused on OpEx, because those are the part that has a major weight for their network. And so how to attack the OpEx is with automation. Automation in all the phases of the network. From the installation, where I need something that will be easy, fast, that allows to speed up the service turn up and the installation time. Those will come with a self installation of the box, will come up with a self setting of the network, will come up then with, during life cycle, a fine grain visibility in order always to understand where the failure is. And then this is a little bit more in the future, is the auto remediation of the network, in the sense the network will make a self-healing, will understand the root cause and will automatically adjust it or reconfigure it without any human intervention. That will be a little bit far in the future. That is from what are the trends, and you can see that most of those trends are what has driven the router optical networking strategy. Because at the end we saw that there is a fast move of the market toward coherent interface. This will allow to integrate optics directly in the router. On the other side, the router is becoming so dense and so scalable that is allowing to mainly transport anything on the network. And then we saw that also the openness and the multi-layer scalability of the software technology allows a completely different way to build the network. So these we make a lot of investment to drive this strategy. We invested on Luxtera to develop gray interface. We invest in Acacia for coherent interface, in order to allow to integrate the different layer inside the pluggable. So we are able to put a coherent interface that is a WDM 400 gigabit capable interface in any route port of a router or a switch. I speak about not only Cisco 8000, NCS 5700, SR9K, 540, Nexus 9K. All of them are now supporting 400 gigabit wavelength directly connected in the router, with a dramatic saving in terms of capex and real estate and power, because at the end I can really not use anymore the transponder shelf, the space of the transponder shelf, the power of the transponder shelf. This is showing a completely different approach. Again, I'm speaking about capex and opex, but also is going in direction what is called the green economy, because we saw that with the 400 gigabit coherent interface replacing a transponder, you can have a saving in power average in the range from 65 to 70%. Then we have different cases with multiple use case with also higher than 70%, but I would say those 68% is a good trade-off about all the different use cases, and this is really implying a dramatic change of the economy. All of those, how it will be achieved is mainly moving from, as you can imagine, from a router plus two gray optics, one on the router and one on the transponder, with a router with directly embedded, of course, the WDM optics, the TSP. And so you can make a very simple math with our M6 chassis. You can have ballpark 400 gigabit every two slot. This means that we have 3 by 400 gigabit transponder per chassis. You can multiply that per number of wavelength. You can imagine how many rack and how much power you have for the rack. Remove all of them completely and replace with a 20-watt WDM interface on the router. The calculation is so direct that everybody understood the advantage. And in fact, now we're not speaking about how we can put and deploy a routed optical network in field, but everybody are thinking when this will be done. The people are simply working on how they need to change the operation, what is the deployment model, but this is becoming, I would say, a common trend in the industry because it is the only solution that can provide so much advantage to the network operator. Of course, routed optical networking is the strategy, but this doesn't imply that we are not innovating anymore in the optical system. Moreover, on the other side, we are dramatically increasing the investment that we are making on optical, because, as I mentioned before, it's true that coherent interface are becoming the mass market, but there are still requirements for ULH market, for submarine system, to have a very high performance WDM interface that the coherent pluggable cannot achieve due to the limited real estate and power envelope that they need to support. So this is why we launched the NCS 1014, that is our high performance shelf. It is very similar to the 1004. I would say I can consider this the next generation that, as a delta respect to 1004, has more capability to support more power, have a new backplane for east to west line card interconnection and the support of directly on the PTP. The key new line card that we launched is the 2.4 terabit line card. You can see this transponder, but again, it is still based on coherent pluggable. It is a different variant of coherent pluggable because we have one line card that can support those pluggable that are CMate. Is a new pluggable that can support up to 1.2 terabit per wavelength. So you can imagine 3 times the capacity of a 400 gigabit QDD pluggable. It can host 2. In fact, this card can support 6 by 400 gigabit as a client mapped over 2 by 1.2 terabit. It can support 800 gigabit. I can make a 3 by 800 gigabit over 2 by 1.2 terabit, but of course the CMate is fully configurable from 400 gigabit to 1.2 terabit. And so I can make also 1 by 800 gigabit mapped over an 800 gigabit. I can make 2 by 400 mapped one on 800. I can make 4 by 100 gigabit with the breakout pluggable, and then combine for 100 gigabit, 400 gigabit, 800 gigabit in any possible variant of wavelength that can be 400, 500, 600, up to 1.2 terabit. The pluggable, that is the major novelty, it is called the CMate. As mentioned, it can go up to 1.2 terabit, and it is the first declination in the market of the 140 gigabaud capability. It is adding the latest and greatest technology in terms of performances, like the second generation of 3D shaping of the constellation. It is based on one of the latest silicon technology. It is a 5 nanometer technology. This piece called JANU, and we can see now that the performance allow mainly to send wavelength 800 gigabit for 90% of the long haul route that existing on the globe. And moreover, there is a major saving in power thanks to the new technology. You can see here the pluggable. So the card, we lost 2 of those units inside the line card. And so, of course, there is the usual trade-off capacity versus distance. The 1.2 terabit wavelength, of course, is for DCI distance 120 kilometer. The 800 gigabit is for metro, regional, and long haul, and the 400 gigabit is for ULH and subsea. There are 2 variants, one C-band, one L-band. You see that the performance at the same modulation will be a couple of dB better respect to the previous generation, and it is based on the silicon technology and the co-packaging of the DSP with the silicon technology of the Acacia team. That is, Acacia was an acquisition that we made more than 3 years ago. The performance are extremely strong. You will see in those slides the fact that we can really cope with any network. We have 900 gigabit per wavelength across 20 ROADM. This is an NCS 2000 network. We can make 1 terabit per wavelength having 14 RODM and 1.2 terabit across 3 per RODM. This means that it can really be deployed on any existing RODM without any risking of too much filtering penalties. But we, of course, can go in distances. Those are, I will go fast, we can make in this network with Windstream, we made 1 terabit at 236 gigabaud for 1100 kilometer. We made 800 gigabit at 1300 kilometer on SMF and through-wave fiber, so going very robust also on high nonlinear fiber, and 600 gigabit at 2700 kilometer, just to give you the power of this interface. We made in Australia 1500 kilometer, 700 gigabit, 400 gigabit, we make 1 terabit at 400 kilometer. Of course, The best will be on the submarine network because we were able to make 6,200 kilometer at 800 gigabit, even if the best spectral density was at 700 gigabit at 115 gigabaud. 600 gigabit we were able to go back and forth with the loopback at 12,469 kilometer at 600 gigabit. But that's not the record. We made the Indigo submarine cable. Of course, we will be able to make 800 gigabit 4,600 kilometer, 600 gigabit 9,000, and the world record of 400 gigabit wavelength 18,400 kilometer. Going back and forth from Singapore, Sydney, back to Singapore. That was just a proof point of the state of the art of the technology of the simulator. Those for transponder. For open line system, of course, we launched the new platform, the 1010. It is a 3RU box that has focused on simplification and automation. The goal is to dramatically reduce the OPEX of the installation and the life cycle of the network, coping, of course, with the real estate state-of-the-art performances. Using this 3RU, you have everything. You have the ROADM, the amplifier, all the knobs to allow to have the full automation. This means that we have inside the OTDR, we have inside the optical channel monitoring, we have inside the noise loading, because to have all the wavelength always loaded in the system. So the amplifier are always working at the optimum setting point. And this means that whatever will be the point of the life of the system, all the channels are fully loaded and amplifier working in the perfect set point. This will represent 1 degrees. So if you have 3 degrees, you have 3 of those chassis. And the only choice that you have to do is I want C or L band, I want EDFA or Raman. But everything is coming in the box, so you don't need to provide line card cabling. Everything is inside. You need only to have to connect to the line or connect to the max stage. And then, of course, there is also another chassis for the line side that it is another 3RU chassis, 300 millimeter deep, so can fit any location in all over Europe, all over the world, because 300 millimeter is de facto standard. And you can see from this picture, everything is integrated. This implies that you have a better MTBF, will have decrease the error in the field, and will allow really to have outgoing field, install the box, connect the cable to the DCN, connect the optical to the line, and that's it. The system will auto-configure with a zero-touch provisioning process, and will also self-configuring the network due to the automation knobs that we have included in the box. And if you remember at the beginning, one of the trends was the L band, and of course we have a dedicated chassis for the L band. So in case in the future want to upgrade, you add the second chassis with all the L band component, and it is a full non-traffic affecting upgrade of the system. The system is coming, of course, with an automation suite. An automation suite that is built with a CONC, that is a network domain controller for enrollment, topology inventory, alarm, service manager, service assurance, and a site manager that is called the COSM, that will provide all the functionality of the local craft, with a lot of tool and application focused on the simplicity and of the manageability of the box. But you will have later on a deep dive on a session about those. I just show you that it is built with application, service assurance, topology, alarming, service manager for the provisioning. Everything is with a nice and modern look and feel. The third pillar is the COMP, the network planner, that will support the full planning and design life cycle of the WDM network, providing any different interfacing, providing the design, the bill of material, the cabling report, and the configuration file for the installation. Part of the automation that we are investing is also a new trend in the technology is artificial intelligence. Artificial intelligence, now is an hype, but mainly for application, for how this can change the life of the work, but it is also application for optical. We speak about cognitive networks when we apply artificial intelligence for optical networking, means that cognitive networks are application of artificial intelligence that can collect data, learn, plan, and decide to act. The machine learning is the subset of AI that is more used. And of course, these entered on the SDN frame, SDN framework, that are, of course, the precondition to see benefit of the machine learning. The use cases are different. We can have network design planning and optimization, leveraging on the AI to find the best modulation, to minimize network margin, increase data rate, leverage to restoration across layer. We can use it for anomaly detection to understand if the network are behaving in a not a perfect way before any alarm. This can be used for proactive prediction of the restoration. Or we can help the user to understand the OTDR trace, because OTDR trace at the end is a graph, and AI was initially one of the initial application of AI was the pattern recognition. So what we have done is, for example, is on the OTDR on NCS 1010, and it is currently shipping, so it's not a science project. The AI can recognize and interpret the OTDR event root case based on the OTDR event graph. We are also working on proactive approach, finding the anomaly on all the data that the networks can provide. And finally, we are also studying the anomaly detection of the DRM green channel through the OCM. Those are all aspects that we are studying with AI. Finally, and the last part of my session is about the coherent interface. We have a wide portfolio. We have Bright, the 400 gigabit Bright ZR, that is the 400 gigabit WDM coherent interface high performance, plus 1 dBm optics power with amplifier and tunable filter. That is the one that we are mainly more success because it's going on any existing WDM system that could be Cisco or third party. It is industry proven that can really go everywhere. We have other variant, the previous version that was the OpenZR Plus, that is minus 10 dBm different by the Bright as a TX power. We have the 400 gigabit ZR OIF typical for data center point to point 120 kilometer. We have the year one gray interface for 45 kilometer distance point router to router. The same 80 kilometer to 100 gigabit is 100 gigabit ZR gray interface. And then we have the 400 gigabit open road CFP2 DCO or the CFP2 DCO by die in case I have a single fiber and not a fiber pair. And the Bright has a multiple proof point that can go everywhere. We have 675 kilometers in Norway, cold across the channel of the channel, 640 kilometers with more than 2.5 dB of margin, everything at 400 gigabit, more than 800 kilometers in India. We have the CPARTEC, the record with more than 1300 kilometers of 400 gigabit wavelength. So this means that can cope with many regional and long haul network at 400 gigabit. Of course, we are not stepping here. We are moving to the next one, that is the 800 gigabit. We already released the Decimate, that was the end, and then we took all the technology and pulled back in order to put on a pluggable. The project is already launched. We expect to arrive to ship by end of this calendar year. We are building a family of product. It is an 800 gigabit ZR, so up to 120 kilometer data center interconnect. A Bright version that is the 800 gigabit ZR Plus directly plus 1 dBm. There will not be anymore a minus 10 dBm interface, of course. This will have the same performance of Bright, but 800 gigabit, so can go in the vast majority of the network. but also we are doing with the same DSP, we are doubling the baud rate, and so we are shooting 400 gigabit QPSK-like, and so mainly we can cope with the 3,000 to 4,000 kilometer network at 400 gigabit. So making more than doubling, making in a factor by 3 the distance that the bride can make. And we expect this is a complete deployment of 400 gigabit over the world. And so now we are at the end of my session. I would like some key takeaways that Cisco is a strong partner. We are really investing in any different company that will help us to provide the better solution for our customer. From hardware, from Lightwire and Silicon Photonics, Liba for Silicon, Luxtera, Silicon Photonics, Acacia, high-speed coherent optics, to all the aspect of the software side to better management in terms of TLF with NSO in 2014, Sedona with the hierarchy controller in 2021, Thousand Eyes, MNOS, Splunk for observability, visibility, and security of the network. That will be a proof point of Cisco continuing investing on performance, automation, and observability. So, final message, digital coherent optics is coming, is currently the main trend in the network. Automation is strong because we need absolutely to simplify the life of our customer, and this can only be done with a strong automation solution. In terms of performances, we are offering the best performances, both in terms of transponder and in terms of coherent interface. And knowing what the network is doing is the key. Thanks a lot.